I guess that's all we're going to get. And all right, so the whole purpose of this class is to get you familiar with the basic layout, operation of an electronic test meter or multimeter. For beginner wise, you don't have to be avionics to go do basic testing, basic troubleshooting. A lot of times you're going to get in the FIM. The FIM's going to tell you to, go to pin A to pin B and check continuity, or, check the voltage at these pins or at these terminals. And just the basic stuff we're going to go through today is going to at least get you familiar with what the settings would be, get you familiar with how to set it up, how to plug it in, and at least maybe what the readings, what the display should look like, so you're doing for the most part correctly. Okay, so a lot of different types of multimeters out here. These are just ones I have laying around here. You're going to go everywhere from, you go to Home Depot or a hardware store, you might have something that kind of looks like this. One of the most common meters around you'll see is made by Fluke. Fluke's one of the biggest makers of multimeters out there. Fluke 117's been around a long time. A lot of use in the trades. You might see it on the flight line from time to time. Very basic multimeter, works great, but we're going to be talking a lot about this one today. Here's a little pocket digital multimeter. All of our stations, I shouldn't say all of our stations, Miami and Baltimore, they both have this one. This is a lot more advanced version of the Fluke. This one has a lot more features. Everything that the 117 has that we just looked at, but a lot of additions, and that's stuff that we'll cover in a more advanced class. This is also a multimeter. This is a Fluke 1587. We have these at the stations as well. This is an insulation multimeter, so not only does it have the multimeter features, but it also has the ability to test insulation by inserting voltage. And again, this will be a more advanced class. This is made by TPI, Test Products International. Test Product TPI, they work with Boeing's troubleshooting division, Charlie Works. They're trying to build us some aviation-based meters. We've never had that before. By aviation-based, I mean, there's a lot of, I should say, more advanced troubleshooting features that we like to see in a meter. Maybe we use 3 or 4 or 5 meters. When I travel, I think if my count's right, I probably carry 6 or 7 different types of troubleshooting meters with me. So TPI's whole purpose in life is to break down that 6 or 7 meters into probably 2 is what their goal is. So this is their first one out. They're going to have another one that combines that insulation test meter, that 1587 as well, but they're not quite there yet. So today, going to keep it basic. We're going to start with this Fluke 117. For those of you that have never used this before, never touched it before, this is your dial that allows you to set to the feature that you're going to do the measurement with. Some of the measurements that we do may be a little bit erratic, depends on what you're doing, and the numbers may be bouncing around a little bit. We can use this button here to hold. When you hit that hold button, it's going to freeze that measurement wherever it's at, so you can take notice of it, write it down, whatever you need to do. Some of the measurements we do, let's say hertz, for example, may have a min and max number, a top and a bottom number. This is going to allow us to see what that number is, the top and the bottom of the range. If we're looking at something like resistance is measured in ohms. It could be ohms, it could be kilo ohms, could be mega ohms, giga ohms, which is factors of 1,000, a million, and a billion. So almost all modern digital multimeters are set. They have an auto range, so it's really nothing you have to worry about. But that's what this button is there for. You can actually cycle through the ranges if you want to. Some of these features, some of these things that we're doing, you can see they have a white letter, and then they have an orange letter, an orange function. This is your function button that's going to allow you to cycle between what these are. This is a light button. It's going to give you a backlight for the screen. And then down here at the bottom, we have our connections for our meter leads itself. So all the multimeters are going to have the same connections. Some might have a couple more, depends on what's built into the meter, but they're all at least going to have these same basic connections. You can see they're color coded. One's black, and the other ones are red. There's always going to be one black. The black is going to be your common or your ground wire. The red ones, depending on the function up here that you want to do. This one does these functions. We're going to go through those in just a second. And this one does just A, which is amperage. Okay. So these functions that we would plug our lead into on this one, by the way, it's either or. You're not plugging a wire into both. We're just going to do some of the basic stuff around this side of the dial. The V stands for voltage. We have AC voltage, which is this little scribbly line. And then the straight line with the dash would be DC voltage. We also have millivolts. So we're going very, very tiny reading, goes down to, I believe it's 3 decimal points off the top of my head. Same thing, here's the AC, and then if you hit the function button, then you can go to the DC for using that. This is our resistance measurement. So this is in ohms. We just talked about that a little bit. This would be our continuity. So really what this is you're going to plug the leads in. It's not going to give you a measurement, but when you touch the leads together, it's going to beep. So you know that you're touching both ends of the wire. We're going to go into that a little more depth and detail in a second. This would be diode and capacitor measurements. When we get to the A's, that would be amperage. We also have the AC and the DC symbol for the amperage, depends on which type we want to do. This would be hertz or frequency, and we have the same thing up on the voltage one. Okay, so what do these things mean? What is voltage? What is amperage? What is resistance? We're just going to touch on that a little bit, not a whole lot of depth and detail, but enough to give you a basic idea of what we're talking about. The easiest way to explain it would be a garden hose analogy. Okay, so you have your garden hose, you turn the water on, you have pressure in the water. Voltage would be similar to the pressure in the water. You can put a sprayer on the end, and if you're not spraying it, that pressure's still always there. Even if you're not using it, the pressure's there. Okay. Current would be the flow, the flow of the water going through. And if you have a larger diameter hose, like a fire hose, you're going to obviously be capable of doing a lot more flow. Okay. Resistance would be, in this case, they're showing stuff that's inside the hose blocking it, or if you squeeze the hose or kink the hose, you're resisting that flow of pressure going through. Okay. And now if we compare this, we've got our water hose analogy here. We've got our pump or our spigot. That would be equivalent to, in this case, a DC circuit. This would be a battery. So our flow of power is going one direction. So our voltage coming through the hose, there's our pressure. It's coming through. Now, it's going to get to our resistance. Our resistance would be a light bulb. And depending on how much resistance is there, is how much amperage, how much flow it's going to draw through there. In the case of wiring, if it's drawn too much flow, we have things to protect the wiring. If it's too much flow and the size of the hose is too thin, it could blow the hose or burn the wire out. We on aircraft and home wiring, we have protections for that called circuit breakers. They're designed for the circuit. Circuit breaker is there to protect the wiring, nothing else. Okay, and if we were to look at this in an electrical drawing, it would look similar to this. Now, I've talked about AC and DC a little bit. Just the basic comparison between AC and DC. DC is direct current. That would be the battery that we just looked at a second ago. So your flow is going one direction. It's going from the battery through the wire to whatever your component that's using that power is, and then back again to the battery, the return path going back to the battery. This is where our garden hose analogy breaks down, really. AC. So AC, the flow of electrons goes both directions. Okay. The speed of that is called frequency or hertz. For your home wiring in the US, your frequency is 60 hertz. Europe and other places around the world, it's 50 hertz. On our aircraft, it's 400 hertz. Now, why the difference? Why do they speed it up so much? When we have the higher hertz, you're able to use smaller components. You're able to make the wire smaller and still handle the amperage needed to run that component. You're able to make the component smaller. And the reason that's important is obviously weight saving. Well, they don't do this for household wiring because when you're talking 400 hertz, works really good in short distances, but when you start doing long distances, it kind of breaks down, doesn't work quite as well. Okay. So going back to now that you have a little bit of theory of what we're doing, let's go back and to actually see how to do it. Give me a second to switch over here. All right. So this is the basic multimeter. Can you still hear me all right?
Yes.
Anybody?
Yeah, we got you.
I'm going to assume that's a yes.
Yes.
This is your basic multimeter. This is the Fluke 117 that we just talked about. Very simple, very basic. In order to use this, obviously we have to have a way to connect this to whatever the measurement that we're going to do. All the multimeters come with leads. There's two colored leads. There's a red lead and a black lead. A lot of multimeter leads come with probes permanently installed. The lead just has these direct wired into these probes. In this case, I have some that are removable, and we can add other accessories on this, such as an alligator clip, or we have pin probes that we can connect to aircraft wiring pins. And these are alligator clips that just plug it onto the end of the probes itself. Okay. So we're going to go ahead and take the leads. The black is always going to go, they're color coded, makes it nice and simple. Black's going to go to common. You're going to stick it in, you're going to wiggle it around a little bit, make sure there's a good connection. You know, if the multimeter's been sitting around a little bit, there may be a little, tiny bit of surface corrosion, but we give it a little wiggle just to make sure we have good connection. And depending on which function that we're going to measure, then is going to be the side that we plug the red lead into. In this case, we're going to do this side and use some of these functions. Okay, same thing, stick it in, give it a little bit of wiggle. And then the very first thing you're going to do when you turn the multimeter on is you're going to go to resistance, which would be the ohm symbol there. You're going to take your leads and you're going to touch them together. Okay. Now, the reason that we're doing this is to make sure we have a good connection in our leads, make sure there's nothing wrong with our wires. And we go and start measuring right away, and you start seeing some weird things, and you chase down a ghost, which I've done many, many times, and then you realize that there was something wrong with your leads to start with. So you always just want to make sure that you're good to go. In this case, our leads are measuring around a 0.2, 0.1, 0.2. And when we're talking resistance in ohms, the lower the ohms, the smaller the ohms. In this case, we had a 0.1, 0.01, means the less resistance going through there. The higher the ohms, the higher the reading, the more resistance that's going through there. Okay, so if we take this, for example, since we're on resistance, we'll just stick with that. We're going to change out our leads here, put some alligator clips on. And we're going to check some wires, check some resistance. Okay, so I've got examples of 3 wires here. This is a 22 gauge wire, this is a 10 gauge wire, and this is a 4 gauge wire. The way wires are measured in gauge is by the size of the conductor. Okay, so the metal part inside, the higher the number, the smaller the wire. Obviously, the lower the number, like 4 gauge, the bigger the wire inside, the more conductor, the more conductors that are in there. Some of the conductors, like home wiring, are going to be solid. Everything you're going to see aircraft-wise is going to be some type of stranded wiring, similar to this. Okay, so we take this wire, we're going to hook up one end. To measure the resistance of this wire, we need to get to both ends of the wire. Now, when we're talking aircraft, there could be times where you have a wire one that's 100 feet long. Well, we don't have leads that are 100 feet long. Depending on what we're doing, in order to get to both ends, we can use the aircraft structure, just like the return path. Well, actually, we'll discuss it in a little while. But we could use the aircraft structure and hook our black lead to the aircraft structure and have someone go on the other end and take the other end of the wire and ground it out and use the aircraft structure to extend these leads. Well, we'll get more into that maybe more in advanced class. But right now, we're going to measure both ends of this. And we got 0.1, 0.2. So basically, there's almost zero resistance in this. It's a lot lower than I can measure with this reading. Okay. Now, bigger wire, would it be more resistance? Let's look. No, it's going to be about the same. So the diameter of the wire doesn't affect resistance at all. The only thing that you're really going to see if it's a healthy wire is going to be length. The longer the wire, it's going to be a little more resistance. It's not going to be a whole lot. And the more that you get into measuring wires and things, the more you'll understand what a good reading and a bad reading would be. Okay. Same thing. We go to the 4 gauge. Same thing. Really negligible resistance based on my leads and what this meter can measure, almost none. Okay. So what would a resistance reading look like if you're on the aircraft? If you're looking through the FIM and the FIM tells you to measure from this lead to this lead or this pin to this pin, most of the time it's either going to have you write it down, but if it's in the FIM, it's going to tell you what it should be if you're measuring through a component, or it tells you to take a can plug off and measure these pins for this component, and it should be 20 ohms. So in this case, this component is 300 ohms. Let's see what it looks like. Okay, 299.2, and I think there's like a 5% or 2% variability in these. Okay, so that's about what it would look like. That looks good. You're talking aircraft components. This is a light bulb off of 747. We go back to our picture that we looked at a second ago, where we have the battery going to the light bulb. The light bulb is our resistor. Okay, let's see what our resistor looks like here. 13, almost 14 ohms. Okay, so we know that's good. If I were to check a light bulb and I were to touch it like this, and this reading instead of 13.8, 13.9, if it looked like this, this means open. This means that there's no connection between these two. So that would mean I could do a quick check of my light bulb or fuse, anything like that, and I can tell if it's good or bad. Right now, that's a good light bulb. If it looked like this when I was touching it, that would mean that that light bulb is blown, or you look at it and see it's blown. Okay, so that's our talking about resistance. Now we're going to move on to continuity. Really, continuity is just checking to see very quickly if the wire goes from this end to this end. Continuity, for the most part, isn't going to do you a whole lot of good with troubleshooting, but it will at least, I would say that most of the time when we use continuity, it's going to be to verify where a pin is going. So if I have one connector and my wire diagram says pin 3 goes from this connector to pin 5 on this connector, I need an easy way to check that. Okay, so most meters, a lot of the newer ones, this one has them separated out. This sound looking icon here is going to on some of the other meters, it's in the same position as the resistance one, and it may just have a button to turn the sound on and off. Okay, so all this does, if I were to go to pin 3 on this side and I'm looking for pin 6, I can just take my probe or my pin insertion tool, or my pin adapter tool, I should say, and go to the other side. And if it's going to the right place, it's going to beep. It's going to make noise. Some of the other meters where it's combined, at the same time it's making noise, it's also going to tell you the resistance. This specific meter does not. It just tells you that yes, you're on the right pin, which really helps out, especially if you're trying to go through and ring out wires. Maybe you repinned a connector and you're just making sure that you get it correctly. Really easy, good way to do it. Okay, so let's see what AC would look like. Okay, so an AC wire, we're going to go ahead and take our red and go to black. For AC, really doesn't matter. This is just household AC here. Okay. And we're going to turn it on. We've got 122 volts. If we were to swap these around, swap the leads, going to read the same thing. Okay, so AC voltage. DC voltage. I'm going to use aircraft pins. Take our adapters here. Now DC voltage, we're going to take our red, and that's going to go to our pin that we're checking our voltage on, that we want to look power. Our black is going to go to aircraft ground. Everywhere on the aircraft, DC, the return path is going back through the airframe. So if we think back to our little diagram we had earlier with the battery that went down to the light bulb, coming out of that light bulb, it's going to go and touch the airframe somewhere. That backside of that light bulb, the wires are going to come out and go to a stud or a pin or a ring terminal somewhere that's going to touch the airframe, so that they don't have to run all the wires all the way back to the battery. Saves weight, less wiring, that type of thing. Okay, so we just want to find a good ground. If you're on the aircraft, best grounds I've found, you'll see the little grounding straps, the little multi-wire grounding straps that are usually bolted to lights or shelves or what have you. They're all over the place. Those are the best things to go to. If not, if you find a good bolt, make sure it's connected. And we're going to switch this to the DC setting. Turn the power on. You can see 29 volts. Okay. So there's an example of DC voltage. Some of our other settings on here. So amperage, for example. Okay, we're not gonna show amperage measurement today, but we'll talk about it just a little bit. If I were to use this meter to test amperage, whether it's AC or DC, in a component on the aircraft, I would have to put this meter in line with that amperage. So I would have to take the wire that's coming into the component and hook it up to my red lead, and then take this out and plug the black lead into the component where the red one went. Most of the time, it's not convenient. It's very intrusive. It's difficult to do, but it is possible to do with this. This is also limited to how much amperage can go through this, mainly by the wire size. You see down here, if you can see it, it says 10 amps. So if you're going to draw more than 10 amps on that, it's going to actually blow the fuse that's in this. It's protected. So you can't blow the meter up, but the fuse would blow. Okay. Most of the time, we're going to use something like this if we're going to check amperage. So what we would do is, if you had your cable on your aircraft, we would turn this on amperage. We would open this clamp up, stick it around the cable, and we would be able to read the amperage going through that wire through that cable. This will be something for a different class, but just so you know, it is out there, and we do have these available. Okay. Really, the last thing on the meter that we're going to go through and show today is going to be the diode setting. So what's a diode? Let's say that this is our water hose and our water's flowing in this direction. Okay. A diode is really a component that allows the water to come. It's like a check valve. Allows the water to come through one direction, but if the water were to come through this way, it's going to stop it here. It's not going to allow it to go through. There's going to be quite a few times on the FIM where you're going to see, check this diode to see if it's blown. Okay, well, how do we check a diode? This is not an aircraft diode. This is just a standard electronics diode. Same principle, same thing. Take one end of your lead on the pins based on the wiring diagram, and we have what they call an anode and a cathode side. Okay, the anode is where the power goes in, cathode is where the power comes out, and it can't go back. So if you're looking at this would be the cathode side. Okay, so our positive, we want to go from positive to negative. So our positive side on the diode, it should only go one direction. So we set this on our diode setting, and we're going to connect to one side of the diode and then the other side, and it's going to give us a reading. In this case, it says 0.164 volts. Now, if this is a good diode and we swap our leads, we shouldn't see anything at all. Okay, open. That means this is a good diode. If this looked the same both directions, it means that diode is blown, and we need to change that. Besides that, that is really the basic functions that you would use on a multimeter. If you get thrown into doing some troubleshooting, this will at least get you by, so you know what you should be looking at and really how you should look at it. What can I answer question-wise? Anything? Who's got questions? Nothing? Nobody? No questions?
Hey, Christian, I don't know if anybody's, how far advanced most of these guys are. If they're
all right.
Green.
I hope you got something out of this. I am here. Anyone needs me for anything, or if you have questions that you don't want to talk about online, just feel free to call me anytime you want.
I'm calling.
And that's it. Thank you for your time today, and you guys have a great day. See you.
Hey, David.
Hey, we couldn't.
Yeah.
Me